what we need to do is, in order to succeed in this lesson, you already need to know how to solve quadratic equations. In other words, solving for the roots of quadratic equations, right? The nature of roots, and that's what we're going to be looking at now. Well, we first need to ask ourselves, what is a root, right? What is a root? And the simple answer to that is the root is simply the x-intercept of a curve. It is the x-intercept of a function or a curve. The x-intercept of a function or the x-intercept of a curve. Okay, now what we are specifically looking at is we are going to be looking at quadratics, and we're talking about curves or quadratic or parabolic curves. So we're going to be looking at the nature of the roots of the parabola or the quadratic function, right? Now, in grade 10 you already learned about the parabola and you learned how to solve for its roots. In other words, how to find the x-intercepts. And what I want to look at now is I want to say, okay, let's look at a specific curve and let's look at a function. And let's say that function looks like that. Then graphically what we would consider that function's roots is where it touches the x-axis. In other words, it's the x-intercepts of the function. And so the roots of this curve is going to be over there. That's root 1. And that's going to be root 2. So I'm going to call this one root 1 and I'm going to call this one root 2. And those 2 points, R1 and R2, these are considered, these two things, R1 and R2, are considered the roots of this function. Okay, if I call this function f is simply giving the function a name. If I call this function f, then those 2 points, the point R2 and the point R1, are considered the roots of this function. Okay, so I can say that R1 and R2 are the roots of f, right? It's the roots of those functions. Now, when you map these functions, in other words, when you're going to draw these functions on the x-axis and on the y-axis, and you map it in this Cartesian plane, then we are mapping things in this Cartesian plane according to the set of real numbers. We're mapping them according to the set of real numbers. Real numbers mapped to real numbers. In other words, you throw in a real number in the function and you also get out a real number. And what we specifically want to look at today is to see, how does this curve move? What type of functions do you get? What type of roots can you get? In other words, how can I move this function around? Okay, and that's what we're going to specifically look at today. Whether we're going to have one root, whether we're going to have two roots, whether our roots will be distinct, in other words, they would be different, whether the roots would be equivalent, in other words, the x-intercept, both x-intercepts lie on the same place, and that's what we're going to be looking at today.